This is section 2.2, part B, the standard normal distribution. All normal distributions are the same if we measure in units of size sigma from the mean mu as the center. This means we have to standardize the units, just like we did in section 2.1. We must find the z-score. Remember, to find the z-score, you're going to take your observation minus the mean and divide by the standard deviation. If the variable we standardize has a normal distribution, then so does the new variable z. Remember, all we're going to be doing is subtracting a constant and dividing by a constant, and neither one of those things are going to change the shape of the distribution. So if the original distribution is normal, the standardized will also be normal. This new distribution is called the standard normal distribution. The standard normal distribution is the normal distribution that has a mean of 0 and a standard deviation of 1. If the variable x has any normal distribution, then we're going to abbreviate this with n parenthesis the mu comma the sigma, where mu is the mean and sigma is the standard deviation. Any area under a density curve is a proportion of the observations in a distribution. Any questions about what proportion of observations, like in the same range of values, can be answered by finding an area under the curve. Because all normal distributions are the same, when we standardize these, we can find the area under the normal curve from a table. The table gives the area under the curve from the standard deviation and everything to the left. This is called the standard normal table. So when you look at a standard normal table, it's going to tell you the area to the left of that z-score. So if we need to find the area to the left of 2.15, the first thing you're going to do is you are going to find the z-value. So we have 2.1 here. You're going to go across that row. Then we're going to go to 0.05 because we're at 2.15. We're going to go down that column. Where that row and that column intersect will give you the area. So this has an area of 0.9842, or 98.42% of the data values fall below that z-score. Remember, this is only going to tell you about the values that go to the left or are less than. Now, if we need to find greater than, remember, under an entire curve is 100% or an area of 1. So if we need to find greater than, or the area to the right, we can take 1 minus the area to the left. So once again, we need to find the z-score first. So we're going to go to negative 1.7. We're going to find that row. And it's negative 1.78, so we're going to find the 0.08. We're going to go down that column. Where those two intersect is going to tell us the area. But remember, that's always the area to the left. To find the area to the right, you're going to take the whole thing, which is 1, and subtract what is on the left. And if we do that, we are going to get 0.9625, or approximately 96.25% of the data in that distribution will be to the right or greater than a z-value of negative 1.78. A common student mistake is to look up the z-value in the table and report the entry that corresponds, regardless if you are looking for the area to the left or to the right. So to prevent this mistake, it's good to always sketch your graph and shade in the area you're looking for, and then look to see if your answer is reasonable in context to the problem. So we need to find the area. We need to find the proportion of observations on the standard normal distribution that fall between 0.8 0.81 and negative 1.25. So negative 1.25 is going to be a little bit more than one standard deviation below. So a z-value of negative 1.25 would be down here. And 0.81 is going to be a little less than one standard deviation above the mean. Remember, we know it's one standard deviation where it changes curvature from curving down to curving up. So we need to find the area between those two lines. Now, from our table, we can find the area to the left. So if I want to find the area to the left of negative 1.25, you would go to your table. You would go down until you found the row that said negative 1.2. You would find the column at the top that said 0.05, and where those two intersect, you would find an area of 0.1056. Now, if I want to find the area to the left of 0.81, again, you would go to your table, you would go down to the column that said 0.8, the row that said 0.8, go across the columns until you found the one that said 0.01. Where those two intersect would tell you the area, and you should have 0.7910. So to find the area in between those two, you're going to take the area to the left of 0.18, subtract the area to the left of negative 1.25, and that will tell you what's left between. And the area between should give you 0.6854, or about 68.54% of all the observations will fall between the z-scores of negative 1.25 and 0.81. You can use the standard normal distribution table to find the corresponding z-scores for any area under the curve. To do this, you're going to find the closest value on the table that is closest to the area that you are trying to find, and then you can find the row and the column that they fall in. Use the row and the column to determine your z-score. So if we go back and we look at this table, if I know I have an area of 0.13, if we look at our table, you're not going to find anything that's exactly 0.13, but we can find this value that is the closest of 0.1292. It is only 8 1,000ths off from what we're looking for. So you would follow that over on the row and on the column, and we would see that the z-score that corresponds to that area, the closest one we have, is negative 1.1, and then we have the 3. So that's how you can use this backwards. If they give you the area, you can find the closest z-score. Now you can also use your graphing calculator to do this. So if you want to draw a standard normal curve, first turn off all the statistics plots. Then you would enter the formula for the standard normal curve into y1. To do this, you would press y1. With the cursor next to y equals 1, you're going to hit second vars, which is distribution, and choose option 1, which is normal PDF. It should bring up all of this back into your y equals, and the left parentheses should be available. Then you're going to type in x, 0, 1, close your parentheses to complete the formula. You're going to adjust the window setting and graph it. The window in this case has an x minimum of -4, so it's -4 standard deviations to the left, 4 standard deviations to the right, with an x scale of 1. Our y-min is -1. Nothing should fall below the graph, so this should get us just a little bit below our lowest point. Our y-max of 5 and a y-scale of 1. If you press graph, it will display the curve. To find the area under the normal curve, you would go to your home screen, and we're going to use the shade norm command. So to do this, you would hit second vars, which is distribution. You're going to arrow right to draw and choose option 1, which is shade norm. You're going to complete the command by telling it a lower bound, an upper bound, the mean, and the standard deviation. Now, if you're wanting to find values that are less than a certain thing, your lower bound is just going to be a super, super low number, and you will know your upper bound. It'll be whatever that z value is. If you want to find greater than, your lower bound is going to be whatever you have as your z value, and your upper bound will be a very, very large number. After each time you use shade norm, execute the command clear draw to remove the shading. So the TI-84 can be used to draw and find the area of their standard curve. So to find the area to the left of z equals 2.22, your lower bound, again, you're going to want to pick something that is super low, so we would say -100. Our upper bound is that 2.22. We have a mean of 0 and a standard deviation of 1. That's going to be this graph on the left. To find the area to the right of -1.78, again, to the left of, we know our lower bound is -1.78. Our upper bound just has to be a super big number, so we can pick 100. We still have the same mean and standard deviation. So this is shading, and it's telling you the area for that graph. And between the two, if you know what you have to find it between, you do have your lower bound and your upper bound. Again, it will graph it, and it will find the area for you. So use Table A to find the proportion of observations from a standard normal distribution that fall in each of the following regions. In each case, sketch a standard normal curve and shade the area that represents the region. So you should always start by drawing that graph. And we are looking at 1.39. So it's a little bit more than one standard deviation. And we are looking at the values that are less than that. So we are going to shade to the left. Now, to do this, you're going to look at your table. You are going to look at the value 1.39. So you're going to go down to the row of 1.3, go over to the column of 0.09, and that should give you an area of 0.9177, or approximately 91.77% of the observations will fall below 1.39. If we want to find all the values that are greater than -2.15, so if this is 1 standard deviation, 2 standard deviations here, so 2.15 would be about here, and we are looking for greater than, so it should be to the right. Remember, your table is telling you the area less than that value. So the area to the left of -2.15, if you look at your table, will tell you it's 0.0158. To find the area to the right, you're just going to do 1 minus the area to the left, and that should give you 0.9842, or about 98.42% of the observations will be greater than a z-value of -2.15. Now to find between the two, again, you're going to start by making your graph. So -1.56, 1.81, we are going to find between the two. So if we find to the left of 1.81, again, you would go to your table, you would go to the row of 1.8, find the column of 0.01, you would see where the two intersect, and they are going to intersect at an area of 0.9649. So that's from here all the way to the left. from here to the left, so to the left of negative 0.56, if you look at the table, that's going to give you a value of 0.2877. So to find the area between, you would just subtract the two areas. And that would give you an area of 0.6772, or approximately 67.72% of the observations fall between the two z-scores. If we need to find the 20th percentile, the 20th percentile is talking about the area. So I have an area of 20% that goes to the left. So we are given the area of 20%. If it's a 20%, you're going to look at your table, find an area that is close to 20% as you can. And the area on your table that is closest to that is 0.2005. Now, if you work your way over to the left side and up to the top to find the z-score that corresponds to that, you are going to get a z-score of negative 0.84. So the z value that would be the 20th percentile would be z equals negative 0.84. If 45% of the observations are greater than, so 45% are greater than, that would be here. Remember, we only know about the area to the left. So if the right side is 45%, that means we have 55% to the left. So our area we should be looking for is 0.5500. If you look on the interior of your table, the closest area you are going to find is 0.5517. And the z-score that corresponds to that is 0.13.